Alright, this is lesson 64, evaluating logarithms using the change of base formula. We've been learning in our class about logs. Logs are the inverse of exponential functions, just like the inverse of adding, subtracting, inverse of multiplying is dividing, inverse of squaring something is the square root, inverse of exponential functions are logarithmic functions. We talked about logs, and in the last few days we've been looking at a few things about logs. For example, we could evaluate a log. Let's say we had a log, we want to evaluate what this is. This is the common log, so it has a base of 10. So we'd ask ourselves 10 to what power is 100? We know that's 2, so we could look at that. And then recently we looked at another one, example, let's say with the common log of 500. Well, I know that the common log of the common log of 100 is 2, right? What about the common log of 500? Well, there is no perfect answer there. But we could estimate it as, we know the common log of, 10 to the power of 3 is 1,000. So it's got to be between 2 and 3. So we could use a calculator, because the calculator has a log button which has a base of 10. And we can plug this into the calculator and we get a decimal answer, right? But what happens when we have, let's think about this differently. What happens if we have log base 3 of 9? Well, there's no calculator button for log base 3, but we know 3 to the power of 2 is 9, right? So that one's easy. But what happens when you have a more complicated problem where it's like log base 3 of 20? Well, I know 3 to the power of 2 is equal to 9, and I know 3 to the power of 3 is equal to 27. So this number has to be between 2 and 3, but what exactly is it? So that's the question we're looking at today. We're going to be using this thing called the change of base formula. So in order to do that, here are the steps. Identify the parts of the logarithms. Pick any new base. See, usually a base of 10 is good. They have 2 buttons on your calculator. They're the common log button, which is a log base 10, or you can use natural log, which is really like saying log base of e. So whichever one is fine. Then we apply the change of base formula and use a calculator to solve the logarithm. Okay. So numbers 1 and 2. I'll show you a couple of them that I taught in class. So log base 5 of 34. Well, the first thing I want you to think about is always estimate what this could be. So 5 to what power is equal to 34? Well, I know 5 squared is equal to 25, right? And I know 5 cubed, 5 squared is equal to 25. 5 cubed is going to be equal to 125, right? So this number is a lot closer to 25. So this number, I'm thinking it's going to be a number between 2 and 3, but really closer to 2, so it might be 2.1. Okay, that's just an estimate, right? So nonetheless, we want to think about this. So the first thing I want to do, here we go, is identify the different parts of my log. So this is our B, our base, and 34. Let's call this M, okay? And I'm going to use a new common log. So I'm going to go to the next step, which is converting this logarithm into a fraction. So I'm going to change this to a common log of 34 divided by the common log of 5. And I've set up my problem. Then I go to my calculator and type these in. Each calculator is different, but I know that most, if not all, calculators have a common log button. When you plug that in, you get a decimal of 2.1910. And then over here, it's asking us to work to the nearest thousandth. So I'm looking at that 1 there that I'm underlining here. Looking to the right, it is less than 5, so I'm going to keep it the same and rewrite my answer as 2.191. Oh, sorry about that. Anyways, that is number 1. Okay, number 2 is similar, right? We got 5, or log base 5 of 23. What is this equal to? Well, I know that 5, if I have a base of 5 squared is equal to 25, which is really close to 23. So I am thinking that my answer has to be not 2, but rather like 1.8, 1.9, something like that, okay? So with that in mind, I'm going to start up my work here. 1.8 is kind of what I'm looking at. Oh, and also on the last answer, Remember I said it was 2.1? Well, look at that. It's pretty close. This one I'm just going to put 1.8 on the side just to remember what I need to have, because I want to have a reasonable answer. Okay, anyways, so the first thing I want to do is identify the different parts of my logarithm. So this is our base of 5. 23 will be our m, okay? And we are going to start working this out. So 5. We're going to change this. I want to use a different button on our calculator. Let's use the natural log button. This is a log of base of e. As long as I have the same base, it's okay. So natural log of 23 divided by natural log of 5. And I'll go to my calculator, type this in. And if you used common log button, it's fine too. We could even use, some calculators have log base 2. You could use that button too. It's totally fine. It doesn't matter. So anyways, we're plugging that in and I get this decimal. And when I work it, I get this answer when I round it. If I'm looking at this 8, looking to the right, it's a 1. So I wouldn't round up. Anyways, these are a couple of examples. This is a quick video. I'm going to show you the answers to the next few problems just for you to practice, but this is really how to do it. So if you want some practice, here's numbers 3 and 4. Pause and try them. Okay, I'm going to move on now. I'm going to show you the answers here. Okay, those are your answers. And here's the next ones. Pause the video now if you wanted to try these two on number 5 and 6. And here we go. Here are the answers. So on number 6, notice that this is a log base 7 of negative 4.8. I put that in there because sometimes we want to just keep automatically going, but remember it's a negative answer, so it's undefined. Anyways, that concludes this lesson.